Welcome to Easy Elimu, Learning Simplified, and welcome to this lesson. In the previous lesson, we discussed kinetic theory of matter and the structure or the arrangement of particles in the three states of matter. And we stated kinetic theory of matter that matter is made up of small particles which are in a continuous random motion in liquids and gases and at a constant vibration in solids. Now in this lesson, we are going to discuss particles which are in a continuous random motion. That is, particles which experience Brownian motion, that is, liquids and gases. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to define diffusion and then describe an experiment to demonstrate diffusion in liquids and diffusion in gases. So what is diffusion? Diffusion refers to the process by which particles spread or move from a region of high concentration to a region of low concentration. So for us to have diffusion, it means we must have the particles which can move. And the particles which can move, we have said they are liquids and gases only, since solids only vibrate within their fixed position. So diffusion is going to take place only in liquids and gases. And the reason why liquids and gases move is because we have said they undergo what we call Brownian motion, that is continuous random motion. And the continuous random motion is caused by the large intermolecular space between them and the weak intermolecular force between the particles. Now, what experiments can we perform to demonstrate that there is diffusion in liquids? What you do, you take a beaker, then you add some water inside, and then you take a funnel, then you deliver through this funnel, you deliver concentrated copper 2 sulfate solution. Concentrated copper 2 sulfate solution is a common solution that you use in chemistry, and it's blue in color. So if you deliver it carefully to the base of this water, then what will happen, you will realize that there will be two layers which will be formed, a layer of water and a layer of copper 2 sulfate, if you deliver it carefully. Then what is observed? What you will observe, if I draw this the structure of what we have just discussed back there, there will be copper 2 sulfate solution which will be at the base, or which were at the base, which you delivered carefully. And then let's use this red to mark water particles. So the layer will be like this. There will be two layers. This is water, this is copper 2 sulfate. Now this mixture, after some time, if you leave it without shaking it, after some time you will realize your mixture or your beaker looks like this. There will be copper 2 sulfate particles all over the mixture, and then the water particles will also be spread throughout the mixture. What does this mean? Here now we will have a homogeneous mixture. This is homogeneous mixture of copper 2 sulfate and water. Now what happened? It means the particles of water moved down. These particles of water moved down, some of them from where they are highly concentrated. Remember, up here we have high concentration of water, high concentration of water, and low concentration of copper 2 sulfate. You have low concentration of copper 2 sulfate, high concentration of water. Down here we have high concentration of copper 2 sulfate, high concentration of copper 2 sulfate, and then we have low concentration of water. Down here we have low concentration of water because we don't have any water particle there. Then up there we have low concentration of copper 2 sulfate. Up here we have high concentration of water. Down here we have a high concentration of copper 2 sulfate. Now after some time, water will move from up, from where they are highly concentrated, to where we have copper 2 sulfate, where we have low concentration. So here, diffusion of water diffusion of water will take place downward. So water will move from where it is highly concentrated to where it is lowly concentrated down there. At the same time, copper 2 sulfate will diffuse or will move from where it is highly concentrated. So we have a diffusion of copper 2 sulfate from down up. So copper 2 sulfate will diffuse from down here upwards, and then water molecules will diffuse from up downwards. In either case, at the top water is highly concentrated and at the bottom is lowly concentrated. So it will move from high concentration to low concentration. At the bottom, copper 2 sulfate is highly concentrated, but at the top it's lowly concentrated. So it will move from where it is highly concentrated at the bottom to where it is lowly concentrated at the top. And in the process, the water molecules will move down, the copper 2 sulfate molecules will move up, and in the process they will form what we call homogeneous mixture. Now, if a hot liquid is used, the formation of the mixture will be very fast. It will take a very short time to form that mixture, and the reason is because when you increase the temperature of the solutions, the kinetic energy of the particles will increase and their movement will also be increased. So since we have demonstrated that liquids undergo diffusion, all particles of liquids moves from where they were highly concentrated to where they are lowly concentrated, it's also possible to demonstrate or to do an experiment to demonstrate diffusion in gases. And what you need is two gas jars, gas jar 1, and then you will have a cardboard which will be sealing this gas jar 1, and on the other side you put gas jar 2. Put the second gas jar like that. Then what you do, one gas jar, let's call it 1, gas jar 1. Here, this is the first one. This is the second one. In the first gas jar, you will put bromine gas inside. You have bromine gas. It is brown in color. So this is brown bromine gas. And then in the second gas jar, you will put colorless air particles. So these are colorless air particles. If I can label them, colorless air particles. So one gas jar 2 will be empty with air, or it will have only air, and then gas jar 1 will only have bromine gas. And then now what you do, you just remove the cardboard slowly in such a way that the two gas jars remains in contact. Then now what you will observe after some time is that after some time you will realize that the brown color of the bromine gas inside will reduce the intensity. If these are the two gas jars, what you will realize here, you will have the brown color, which is now pale brown. It means the particles have interacted. The particles of air with the particles of bromine have interacted to form what we call pale brown color. Now, what happened such that the two particles interacted? What happens is that the particles of bromine diffused, because in this place here we have high concentration of bromine, and at the same time we have low concentration of air. So in the first jar we have high concentration of bromine, and at the same time in the first jar we have low concentration of air. In the second gas jar we have high concentration of air, and at the same time we have low concentration of bromine. So the two gases will move from where they are highly concentrated to where they are lowly concentrated. So in the gas jar with bromine, the highly concentrated bromine will move to where it is lowly concentrated in air. And at the same time, the highly concentrated air will move from where it is highly concentrated in the second gas jar to where it is lowly concentrated in the first gas jar. So this is bromine moving in this side. This is bromine moving, and this is air moving to this side. So in the process, air will move from where it's highly concentrated to lowly concentrated. Bromine will move from highly concentration to lowly concentration. And now when they mix, the particles of bromine will split through the two gas jars, and even the color will be less dense, that is pale brown color. And that one now proves that gases can move from where they are highly concentrated to where they are lowly concentrated. But it's important to note that when you increase the temperature, or if you perform this experiment at high temperature, the pale brown color will be formed very fast. And the reason why the pale brown color will be formed very fast is because as you increase the temperature of these particles, the gases particles will gain kinetic energy and their movement will be very fast. So diffusion takes place faster when the temperature is high and low when the temperature is low. So why is it so that gases move faster or diffuse faster than liquids? The first reason is that gases have low density. Low density means they have all their light. They can be moved easily. They are light and they can move easily. So particles which are less dense moves fast, and particles which are low density means they are very heavy, they move very slowly. Another reason is that gases have high kinetic energy, the energy which causes motion. So the kinetic energy of gases is very high, and especially when you increase the temperature, the kinetic energy will increase exponentially and the gases will be moving very fast. Now, the third reason is that gases have very weak cohesive force. If the force of attraction between the molecules is very weak, then it means the particles are free to move. Now that marks the end of our lesson today, and in the next lesson we will look at these gases which can move faster than liquids. Do all gases move at the same speed? That's what we're going to look in the next part. We're going to look at rate of diffusion of gases.